So with that, let's do the playing with the ChatGPT that I've been doing. And unlike when I do the timed assessments, this actually is something that I might recommend. And I think I heard from one of your classmates that when she worked through homework, she asks ChatGPT for kind of problem solving tips. All those are fine as long as it's helping you learn. And how did it help you learn? My tester for that is the one-on-one meeting, and you can simulate that environment to yourself. So any questions that you work out with help, wait a day, like after a day, go back to that same question and see if you can do it again without that help. If you can, then great, you've learned something. And with any learning, you do forget it from time to time. Like my goal in learning every semester is to learn all your names. And if you take my physics 4B next semester, I will probably remember your name. But if I run into you in the middle of the semester and you are not in my class at the time, don't be too surprised if I can't remember your name, because as much effort as I put into memorizing people's names associated with their face, like once I'm not seeing you regularly anymore, I let it kind of pass away so that I can memorize new people's names. So, really what you are learning in class like this is two things. One, how you study, how you learn for any future things you have to learn. And two, there are some core concepts that you won't forget. If you learn to ride a bicycle, then even when you get out of practice, you never truly forget it. And there might be some core concepts in problem solving that you would never forget. But those are like basically one or two core thing. It's not any of the formulas, even standard strategy. I wouldn't be too surprised if those of you who have actually learned the standard strategy, which is already a pretty small fraction of the class, those of you, if like half of you don't remember the 4 steps of standard strategy a year from now, it doesn't surprise me that there's a sort of recency thing. So anyways, while we are learning the course content this semester, let me bring in, so I think I want to turn into test student here so that I can access the problem set as you would without any access to the answer key. And I've mentioned many times, test student is my worst student. And one of the nice thing about having done these loosened module requirement is that it's a lot easier for me to clear the module requirement for the test student, rather than having to go in as an instructor and give manual excuses. I can just do this, and I think it might take a second or two to So I can access problem set 9 due this coming. I don't know. It's not due Tuesday 7 a.m. It's Monday midnight. It's a time zone issue. For whatever reason, my Open Math right now thinks I'm in a different time zone. Probably Greenwich Mean Time, I think. Monday midnight, according to Pacific time zone. So let me start. And I click zoom out a little, and let me bring in ChatGPT so that I can ask. And let me make sure I'm in the O1 model, and I've demonstrated this many times before. If you simply ask a question from the set to the ChatGPT, it'll simply answer the whole thing, and I strongly recommend against doing that. One, if you are simply copying what ChatGPT gave you, then you are in violation of honor code. Everything you submit should be a reflection of your work. Now, that doesn't mean you can't have help, especially for homework. You are allowed to have help. You are allowed to have a tutor. You are allowed to ask me. You are allowed to ask a ChatGPT. Really, what you have to make sure is that before you submit it, you have to make it your own. You have to, so that what's being submitted is your own work. So let me just type in my usual initial prompt so that when I ask ChatGPT a question, it won't give me the whole answer right away. Because when it gives you the whole answer, you could try reading through it and making it your own that way. But I think a lot of us are really much more capable of fooling ourselves that we understood what we read than actually understanding something on the first read. So, um, I'm here to work on um, rigid body motion problems from my university physics class. Um, and I really need to make sure that I am learning the material as I will be quizzed on the same questions next week by my instructor. Can you I'll try to describe what I've done so far on each question, and can you please not give me the answer right away? I just want help with the step I might be stuck on. So, it'll acknowledge. Um, Let me see. This one seems a little too easy because you can just do 150 times 0.14. Ooh, can I do that in my head? I don't think I can do that in my head. Although, um, there is a calculation I can. So I can't do 150 times 0.14 in my head. Two-digit multiplication, a little too many numbers. But I can do division by 7. And I think a multiplication by 0.14 is close enough to division by 7. So if I do that, then it's gonna be 2, 1, 0.4, maybe. I knew I was close, just outside the 1% range. So, yeah, this is a pretty easy question, so I'll skip it, or I won't ask a ChatGPT because there's no point to it. Now, I don't think a ChatGPT still can draw free body diagram, but let me ask. I'm trying to draw a free body diagram for this question. Can you help me with that? It. I don't think it can do free body diagrams still. I mean, they are updating model from time to time, and I've seen it on ASCII art, and there was something that made me think maybe it can do free body diagrams now. It might be the ChatGPT 4.5 model that I'm thinking of, but yeah. So ChatGPT will be able to do this for you. It can describe the forces, but it won't be able to draw it for you. If you keep insisting, it might give you an ASCII art. And with this, it might give you a correct one. But once it starts involving oblique angles, I've seen the ASCII art drawing is so confusing. Now, this question, let me see if there's a let me see if I can try following this instruction to just draw free body diagram. Let's see how easy ChatGPT's instruction is to follow. So it says, and I guess I'll just draw it right on the picture here. It's not what I normally recommend, but I've seen people do it, and it's there are a lot worse things people can do. So I'm not gonna yell at you necessarily. Weight of the bigger boy. So the bigger boy is on the left. Okay. So there should be weight x downward at the point where he sits, m1g. And then weight of the smaller boy uh, acts downward at the point where he sits on the right, M2G. Weight of the seesaw board acts at the board's center of mass at the geometric center. Yeah, it says uniform. So center somewhere here. And I'm gonna say B for board, BG. Fulcrum's support force. Yeah, so this is the kind of force that people might have forgotten, which is great. There's a pivot force here. I think for the purpose of this question, even if you have forgotten the pivot force, you could have gotten the correct answer. You just make sure you choose this as your center rotation so that the pivot force exerts no torque. Let's upward at the, yeah, good. Mark the positions on the seesaw. The pivot is at, yeah, that's already done. I guess I could say this is X pivot. The board is 8 meter long total, so the center of mass is at 4 meters from either end. So it says 1 meter to the right of the pivot, so I'll label that 1 meter to the right of the pivot. Bigger boys at the left hand, 3 meters. So I guess I shouldn't label this as X pivot. So the pivot is really, even though it said X equals 3 meters from left hand for pivot, really I should be treating this as my X equals 0. But I can say this is the, well, I'll just leave these labels alone, and I can just use these numbers for the lever arm value later. All right. So draw the diagram. Using the diagram that's already there at the midpoint. I thought as you are reading these, you should have done that. But if you didn't do that, then okay. Number 3 here is a reminder that you should have drawn what you saw me draw. That's it for the pre-fiber setup. All right, so let's do this. Rather than trying to find a mistake, let's say I've drawn the diagram because I'm remembering standard strategy, and then free body diagram, or I guess it's more plausible if I say I don't remember standard strategy. Let's say you're just drawing the blank. Maybe you're tired, you're not sure where to go from here. So, okay, I have the diagram, but I'm drawing blank right now. What do I do from here? Newton's second law. Maybe you remember a part of standard strategy. It should give you static equilibrium condition, because from the question text they should have gotten that it's conditions for equilibrium, and that does involve Newton's second law for translation and rotation. So yeah, rotation is the important one. You'll most often start by network about the pivot, and since it's saying all that, let me not make an unreasonable mistake. Let me be reasonable, and I will pick this as my pivot point, and just and then let's say I've forgotten everything and I'm too tired to look it up from textbook. So I'll ask, and how do you write down the net torque? So you should know the definition of torque, lever arm times force. Sign convention, yeah. So one direction positive, another direction negative. Counterclockwise, that's the one direction that's common in geometry, as from positive x-axis to negative x. That's usually what we said is positive. But you can flip them around, because sometimes counter shouldn't that be negative? Doesn't matter, just be consistent. Torque is, that's redundant. Lever arm means perpendicular. So yeah, force times lever arm. So identify each torque sign. Yeah, so these are all great steps. So you can follow all that. And it's given you a little too much, because I think having gone to this far, it is better practice for you to then do the rest to yourself. And I think this is the thing that you have to do for yourself. Once you kind of recognize, did the ChatGPT give you too much help, then, don't scroll all the way down. I think if you needed a reminder about how torque is defined and all that, then I think you've had enough from this description here. And this list gives you everything you need. choose a sign convention. Okay, so I say, all right. So I'm gonna say counterclockwise is positive, clockwise is negative, clockwise is negative, and you can go through the practice of writing this out yourself. M1G times the lever arm, 3 meters. Don't confuse the M's. Minus MBG times the lever arm, 1 meter. And then minus M2G times the lever arm, 5 meters. And once you've written it down, then you can scroll down and see, oh, did I do it right? And yes. And I guess you need to do the algebra. I think this is an easy enough algebra that to mess it up would be a little unrealistic. So let me do it in my head. I guess even easy algebra, as you are doing it in your head, I could make a mistake, but I think if I do, I'll get a negative answer, which will be unreasonable. Uh, so yeah, I'll just do the algebra. So MB, having done all the steps in my head, MB should be. Oh wait, let me just do this step on paper. Just cancel out. It should be M1 times 3 meters minus M2 times 5 meters divided by 1m. And one nice thing about that is you can say, oh, the meters cancel out. I don't have to worry about it. So, yeah. And if I I guess I could make this sign error. I could say, oh, I made an algebra mistake and add it instead of subtracting. so if I made a mistake, then I'll get on the wrong answer. So let me I'll just get the number, ask ChatGPT, hey, I did all these steps. I think I did it right. What am I missing? M1 is the larger boy, I think. Yeah. And the other mistake you could make is swapping these two, but that'll, I think, result in a negative answer, which will give you a hint that something's wrong. 83 times 3 plus 45 times 5 is equal to 474. So you say 474 kilogram, which again is wrong. Oh, wait, I should type it in. 474. That's it wrong. So I asked ChatGPT. It's hard to show everything. I followed all the steps and I think I did it right, but it says it's wrong. Can you tell me where my mistake might be? It's been hit or miss if a ChatGPT fully follows my written work, like actually spotting this sign error. Because it is messy, and like these extraneous text could be confusing, but we'll see. And this is the use of generative AI that I think is something that is truly new. Because in terms of getting the right answer, you got the homework helper videos, and I'm sure there are enough solution manuals floating out there that you can find those. Those have limited educational value. Even my own homework helper videos. I mean, I have it as a demonstration, but I did it knowing that people who have watched through those videos might not fully understand everything that happens. What's wonderful about generative AI is they can give context-dependent feedback, as if you are at my office hour. It's not as good as me, but like if you're working on homework at 3 a.m. in the morning and you know that I'm not gonna respond until later in the morning, then it's ChatGPT can give you immediate answers. So let's see if it mixing up the sign of each torque. So I can say based on this, I didn't do that. I put, plus, minus, minus. I did all those fine. Um, so yeah, so I don't think it's giving me an answer that's actually. Oh, wait, wait, wait. If when you're adding torques from, okay, yeah. Let me see if you. So let me see if I divide it up line by line, you can follow. So um, I'll ask. This is how I set up the network equation. This is correct, right? Should I say that looks correct? And maybe having fed that first, if I feed the next line, then it can spot the algebra mistake for me. Because, giving kind of this more generic, what's the most common fit follow, that can be helpful because sometimes, people make a common mistakes, but maybe you mistakenly think you didn't make that common mistake because you are too smart to make the common mistake. So your signs look correct? Yeah, okay. Here's fine. Ah, maybe. Yeah, 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 yeah. That is the thing to check. Uh, okay. So, but let's say I convinced myself that I did algebra carefully. So I'll ask. Uh, so I think I did the algebra carefully in my head. Um, can you tell me if this looks right? And maybe going step by step, it'll be able to tell me that plus sign there should be a minus sign. Ah, yeah, 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 yeah. Yeah, that's great. Yeah. So, if it doesn't spot your mistake from the whole thing, I think if you feed it line by line, which might take longer, and if you're using O1 model, I'm pretty sure you'll run out of O1 responses pretty soon. So, use ChatGPT 4.0. I'm sure 4.0 is also pretty good. I like O1 better, but 4.0 might be serviceable enough. And when you break it up, yeah, yeah, spotted a mistake. Um, so I'll say, oops. Uh, so I guess I should actually do the correct thing and then uh, oh, guess the new calculator 83 times 3 minus 5 times 45, 24. Yeah, I get 24 kilogram, and that seems to be correct. Um, yeah. So was a pretty easy question. I'm just, dragging it out because we got, oh, wait, don't have that much time. Only 30 minutes. So let's get a substantial question and not make trivial mistakes that, I'm sure many of you are watching thinking, yeah, I'm not going to make that kind of mistake. That's way too dumb of a mistake to make. So, let's see. Do I want static equilibrium? I think a static equilibrium. Well, maybe there are more interesting questions involving gravity. Um, this could be an interesting question, mainly in the sense that you follow standard strategy, and then at the end of that, you might get stuck because it's asking for the minimum angle at which something happens, and that's not the usual question we ask. So let's say you are trying to follow standard strategy. You do the normal things we do. And actually for this, even though it looks like an extended body, I think you're going to be fine if you just draw regular point mass free body diagram because there's no torque being exerted by anything. This force has zero lever arm about that point. So I'm just going to draw regular force. Thinking through this, let me draw gravity. I don't think we are given the mass of the pencil, so it ignores the weight of the pencil. So I'll say it's 0 later. Um, So you think through, okay, what forces do I need? I need a normal force so that the pencil is not being pushed downward. And then I'm looking at a coefficient of static friction. So I'm given the coefficient of static friction. That's one reminder that you probably should identify friction force in your free body diagram. And also without slipping. So here, the way to draw right now, it looks like you could have leftward acceleration. You don't want that. You want it static equilibrium. So for that, you need the friction force to the right. So that's step number one. Step number two, define your coordinate axis. I guess here I would define it the normal way. Yeah, normal way is fine. I could make a plus x go to left, but it's fine. Doesn't matter. So that's step number two. Step number three, break forces into components. So for this force, I'm given this angle theta. So work through the geometry. This theta should be that theta. Or you don't actually have to do that. You could draw this right triangle instead. If you draw this right triangle, then you got this force component and that force component, and they are the legs of the right triangle with this as the theta. So Fy is the opposite side, so that should be F sine theta. Fx is the adjacent side, so that should be F cosine theta. Step number 3 done. Step number 4, write down Newton's second law equations. So I write down net force in the x direction is friction minus F cosine theta is equal to 0. Net force in the y direction, n minus mg minus f sine theta is equal to 0. And then you remember, ignore weight of the pencil, great. And then you go as far as saying my friction force is less than or equal to the static friction coefficient times the normal force. And I think you ought to run into a problem in that too many unknowns. So your friction force is unknown. Let me highlight the unknowns. So your friction force is, where's my, that's a disappearing pen. I wanted the highlighter. Friction force is unknown. My applied force is unknown because it never gave me the applied force. It's asking me for angle, so the angle is unknown. Normal force is unknown. That's already 4 unknowns, and no new unknowns here, but I got 4 unknowns and only potentially 3 equations. So this is where I get stuck and ask ChatGPT for help. So let's see. I'm not quite sure how I can get what the question is asking here. I followed the instructor's standard strategy and wrote down the Newton's second law equations, setting net force equal to 0 for static equilibrium. But I have 4 unknowns and only 3 equations. Do I need a net torque equation? I thought about that, but I just took 0 equals 0 for that. Oops, I already pasted it. I'm just, doing this to confuse. When you are trying to get help from ChatGPT, you probably shouldn't deliberately try to confuse it unless, you genuinely thought maybe you were missing that torque equation here, because that could be your 4th equation. So what ChatGPT should coach you through is maybe practicing kind of reading the question and looking for this condition somehow. Wait, April 13th, when is that day? Oh, that's okay. Good. That's near enough. I need some of these to write the lecture comprehension questions. But I think I'll have enough for now. Have enough for upcoming section at 2 p.m. and it'll be fine. You still need friction in addition. Okay, yeah. No, this is wrong. That's not my fourth equation. Um, that's my third equation. Yeah. Um, okay. With the friction equation, I only have three. Can you list the four equations you see for me? Sometimes it realizes that it hallucinated a response earlier. Yeah, it's not being helpful. Hmm. Let me try O3 mini high. Um, maybe. That'll also help me save some of my own responses. Um, it might be just stuck here. It's possible it's a way in which I asked the question. So after I get a response, if it's not helpful, then sometimes when you get stuck, the thing to do is just backtrack, go back to the beginning, and restart. So even though I was, trying to ask a ChatGPT, don't give me too much help. I need to learn. But right now, it's not giving me any help at all. So it's possible that if I just ask the question from the start, without giving it kind of none of these steps are wrong, by the way. It's just um, I think it being stuck in what I've already done, it might be kind of in a dead end line of thinking for some reason. um, 'Cause so if it doesn't give me helpful response, I will um, switch approach and think for conditions. Okay, did that. Particle component. Did that. You have a sign error. That's fine. Yeah. Um, torque. By the way, this is not relevant for well, it's static equilibrium where net force is equal to zero. Like uh, choosing different pivot point won't give you any new information. Here, like so, even if I chose this pivot point so that the torque to force and normal force are not zero, I don't think that would actually add to any new information. So this I don't think is helpful. Yeah, yeah. So it's stuck at giving me those four equations. This again doesn't. Yeah, so this doesn't help. But it's possible that it's not being helpful because I kind of cornered it into unhelpful line of thinking with my focus on, hey, do I have enough equations? So let's just backtrack and just start it from beginning. I'm still on do I want let let's just try switching to O3 mini high. And I'll say I'm still stuck. Let's start from the beginning. How would you suggest that I approach this question? And oftentimes, redoing the things from scratch is easier than trying to correct a fundamentally incorrect approach. Again, nothing here is actually incorrect. It's I think the thing that I asked the ChatGPT that buys this the whole focus on the number of equations and static equilibrium. Do I need to use torque? That red herring I think is confusing it. Here you are better off with just ignoring torque because torque doesn't give you any information here. So the response it should give me is basically you can set up a condition. I think what would work out best is almost treat theta as known and solve for f. As you solve for f, you'll get basically f as a function of theta. And you will be able to find the situation where f approaches infinity and the angle theta that allows that to happen, where applied force can approach infinity before this slips. That's the angle theta you're looking for. Um, so identifying theta is unknown. Maybe that could be deemed as a mistake, but it's an easy mistake. They were asking for theta. Of course, I don't know theta. Um, but here, my approach would have been let's solve for f. Try to get an expression for f and interpret that to try to get answer to theta, which is a little again. If you haven't seen problems like this, I think I had a timed assessment question back when we were doing forces and motion that was like that. It's I think pull with the friction question. One of the parts becomes push with the friction, and what I'm asking there is actually exactly this. And I could have asked it earlier because again, this setup doesn't involve torque at all. Yeah. Okay. All right. Yeah. So those are all the conditions you need. Yeah. Have that. Have that. Write the force balance equations. Okay. Done that. Done that. Um. Yeah. Friction condition. Done that. Solve for theta. That's not what I would have done, but let's see how that works out. Uh, oh, maybe you could then have f approach infinity. Maybe. So f cosine theta is mu. Yeah. Cancel f. Oh, that's interesting. This might be right. F cancels out. Does it? Yeah, F cancels out. Oh. Well, 1 divided by 0.64 is equals arctangent 57.4. Yeah, yeah, yeah. Oh. So that's not the approach I was saying I would do, but obviously worked. Let me make sure that my approach also gives the same answer. Just out of curiosity, and do I have time? Let's see. Yeah, I have time. We have enough time for one more substantial question. So what I said I would do is let's treat theta as known and just solve for f. So if I'm doing that, I do want to eliminate friction. So I have so plugging this into here, I have f cosine theta is equal to mu Sn. And I have n is equal to f sine theta. Oh, I don't think you can solve for f. Or can you? Let me f cosine theta is equal to mu s f sine theta. Yeah, I don't think you can solve for f actually here. So because you try to collect like terms with the f, you say f is Oh, but I think you can do it this way. So so in trying to solve for f, this is the expression you would come across. F times, so having moved this over and then factoring out f, again, attempt to solve for f, you get f times cosine theta minus mu s sine theta is equal to 0. And if you are still trying to solve for f, you run into a problem because then you get an answer f is equal to 0. And what does that mean? And that's at that step where you could look at this algebraic expression, try to interpret what this means, and this means, oh, this thing here, in order for the conditions that I was specifying here to work out, that means that this should be equal to 0. And doing that, I think the rest of the steps basically leads to what ChatGPT was doing. Yeah, cosine theta is equal to mu sine theta. That's what ChatGPT had. So different roads, same path. Maybe this is a more of a standard, straighter path. Let me ask you this one last question, which I think you should also, especially when you've basically gotten the whole solution, then again, a lot of us have greater capacity for fooling ourselves into thinking that, oh yeah, I read that, I understood that, than actually understanding it. So one thing you should do that I can demonstrate right now, leave for a bit, come back in 6 hours, a day, and then see if you can redo this question without reading this again. If you can, then great, then you have actually understood what you read. If you can't, then you should then you should struggle with it some more. The question that I want to ask is, oh wait, it actually did even solve for yeah. So all right, I calculated theta is equal to 57 degrees, and that seems to be correct. So I would ask, but how do we know this is minimum angle and not the maximum angle, or maybe the only angle where this works? It does come down to if it's any of these other conditions, your expression for friction has to change, because you are using when you use the equality portion, you are using the condition that static friction force is equal to its maximum value, and it can be less than that. That would basically cover all the cases where theta is greater than this, because at theta greater than this, you don't need the maximum value of friction force. Is minimum angle, x angle, yeah, in equilibrium, yeah, inequality. So when you write this, and notice that required friction force is this, and the maximum available friction force is, and you can actually set it up as inequality. Then you can. Oh yeah, I think that's what it's doing here. So rather than setting it as equal, you can just leave it as inequality and keep working through. Then you can get inequality for theta. Yeah. So, but yeah, see, that's great. So use the remaining 8 minutes to find a question, maybe a gravity question that's interesting. Let's see. Oh, maybe I can ask ChatGPT to give me a scaling argument. Because one of your questions should be a scaling argument question, and maybe not. This is more of a Kepler's third law question, I think. Even the hint might, yeah, it's not scaling question. I think I just didn't end up getting a scaling question here. Yeah. So let me do it this way. I'm gonna see if one of the other two questions are scaling argument question. Probably not. Okay, so I think one of the four questions here is a scaling, or yeah, one of the four questions here might be a scaling argument question. Yeah. So, there's a way to do this question in a way where you go through all the proper mathematical expressions. So you go through all the information that they're giving you. Acceleration due to gravity is 5 times as large. So you say, all right, so Fg1 is equal to 5 times the gravity on the surface of Earth. So I guess I'll say F lowercase g, which I could rewrite as 5 times g times mass of Earth times the mass of the object divided by radius of Earth. And the mass density of the planet is known to be 2.5 times that of Earth. So that tells me, so the planet, so mass of the planet divided by its volume is 2.5 times mass of Earth divided by Earth's volume. Okay. And it's asking what is this expression here. So there's a lot of detailed 4/3 pi rp cubed. V is 4/3 pi re cubed. And you can go through all that. So let me just write down the left hand side, and let me actually organize this a little bit better, because I've seen ChatGPT not quite get the order of expressions correctly if I don't have them right, top to bottom order, or and it's top to bottom and left to right. Some of these, I would say. So in this expression, I wrote down the right hand side in terms of the one on Earth, and I can write the left hand side in terms of the gravitational force on the of the planet times the mass divided by radius of the planet on the surface of the planet. So let's just keep chugging away. So let's just simplify a little bit. I'm still doing proper algebra, but simplifying the common factors. And I'm trying to solve for radius of the planet in terms of radius of Earth. So I can imagine, okay, here I think I can do that. Just move the terms around. Then I get RP is equal to, so RP is over there, RE moves over there, ME moves down here, 5 moves down there. So it's MP divided by 5 ME times RE. And then you notice this ratio, and then so you try to work out the ratio here. So so from here, I guess I can do MP over ME is equal to 2.5 VP over VE, and then plug in these expressions to get 2.5 4/3 pi rp cubed divided by 4/3 pi re cubed. 4/3 cancel out, pi cancel out. So I plug this in here, and I think I still need a bit more algebra. Let me just make a little room here so that I can paste it in more cleanly into ChatGPT. So combining this with this, I have RP is equal to 1/5 times that ratio, which is this, 2.5 RP to the third power RE, and this will mess up our algebra, so I actually have to solve for that, the RP again. This cancels out one factor, so I have RP squared over RE squared. All right, let's move the stuff again. So RE squared to the left-hand side, and then swapping the sides around. So having done all that, RP squared is equal to 5 over 2.5 RE squared, and you're taking square root, so those will go away, and this coefficient here will be square root of. So I can put that into calculator. Divide by 2.5. Oh, square root of 2. 1.4 something. 1.41. Yeah, I don't have square root of. I have it memorized 1.4, but I don't think that's within 414. Did I make a mistake? I made a mistake. What mistake did I make? I mean, this is the proper way to do it. If anything, I would have made a mistake going the other way. Acceleration due to gravity is 5 times, 5 times Earth. So solving for RP, yeah. And the ratio of the masses, MP over M, is 2.5 BP over E. That's the 2.5 times that of Earth. So it needs, let's see, well, I can actually do this. I made a mistake somewhere. Let's ask ChatGPT. And so here it's not an intentional mistake, but hey, I meant to ask ChatGPT about actually something else, about something called the scaling argument. But you know what? This question is fine. I I can. I'm working on this question, and I can't seem to find my mistake. Can you help? Possible there's a programming error. Um, oops. Let's see. I can try doing the scaling argument thing that I was gonna ask a ChatGPT for. So the scaling argument would be, gravitational force being, being proportional to product of the masses divided by R. Oh, this is the mistake. It's R squared. Yeah, so let me fix that mistake. Let's see if ChatGPT spots that mistake that I forgot to square the R in the universal gravitation expression. Well, I found a mistake, so let me fix that properly. And then, unless the ChatGPT finds it before I do. So, wait, did it find it before I do? So as you are reading this, you might realize the mistake. Then great. Uh, yeah, and it did get this different answer. So common mistake, unnecessary square root, or just having on wrong RE. Yeah, so it's just listing a common mistake, but not finding my specific mistake of remembering the universal gravitational law wrong. Let me just finish writing this and then end with the question that I intended to ask a ChatGPT. So with this square, then then the it becomes a lot simpler because with this square thing now it's just RP over RE. So yeah, so you don't have the square root thing. So it's just 5 or 2.5. Yeah, so it should be 2. Good. All of that fine. So I'll say uh, okay. Thank you. I found my mistake. Um, The instructor says that all this algebra is unnecessary. Found my mistake. I forgot to have a square for the inverse square. But the instructor says that all this algebra is unnecessary. If we use scaling argument, can you explain that? And one of the beauty of scaling argument is that because it relies on simple relationships, it kind of helps you avoid mistakes like this, where you can get lost in a complicated expression. Um, Let me see how ChatGPT explains a scaling argument, and uh, let me see if it sounds good to me. And if it does, then I'll wrap up this session. Um, Identify the scaling relationship. Yeah. So yeah, that's what I was leading to. Well, that's this relationship here with the mass relative to the volume, or so this would come from well, density being the mass per volume, and the volume scales as the radius cubed. Um, and yeah, surface gravity is given by that mass per r squared. So mass scales as that. So put that in. So the surface gravity scales as density times rho. Much simpler algebra than when you're keeping track of all the coefficients and all that, like 4/3 pi. Not needed if you're using scaling argument. So in comparing to planets, you're basically given two things: that gravity on the surface is different, and the density is different. So you can form these ratios, and with the scaling arguments, once you form the ratio, then you have equality. On the left hand side, from the given information, you have 5. On the right hand side, the ratio of the densities will give you 2.5. So you get to this much simpler expression. And a lot of times with the scaling argument, you can make it simple enough that after you've written down first the initial expressions, like do the rest of the calculation in your head. 5 divided by 2.5, 2. So yeah, avoid the colorful algebra. Yeah. It's the kind of argument that a lot of physicists prefer, but sometimes I think I see students who feel it looks like they feel uncomfortable with such approach. I would say time to practice is now, because as you see other more complicated scenarios, the simpler approaches, you'll find that they help you. Um, Simpler approaches are easier, and they actually help you avoid making mistakes. Like this mistake that I made here, I would have never made a mistake if I was looking at scaling relationship. So